He's a co-founder of the Water Furnace International Incorporated out of Fort Wayne, Indiana, and he's presently president of Canadian Earth Energy Association. Please help me welcome David Hatherton from Canada.
Thank you. We didn't even meet yet. I'm really taking the place of Peter Scott Smith, my cohort. Peter's has something going on. I think he's just very busy with this program that's going on up in Ontario, and decided that if he left his desk, he'd come back and it would be 2 feet thick. We've had a incentive program take place in Ontario. It took us about 3 to 4 years to get this program online. I'm going to go through where I think the technology has come from. The speech is really what's the future, but I think you have to try to understand where it came from and why it's here beyond just some of the simple technology of taking the heat from the ground with a bunch of pipes. I think everybody here is probably very familiar with that now. You've had the best and most expert people probably in the world, I would say. Harry Bro, Jim Bowes, Dan Ellis, a number of people that I've been associated with for close to 10 years. So you've had a real good look at where the technology is. You're starting to get a glimpse of why the utilities are involved in it. When I started into this, it was just, we had an energy crunch. This was back in the early 80s, very early, like 1980. And oil prices were going up. There was oil shortages, all this shock stuff going on. We didn't have a tentative war in the Middle East, but we had some other things that were going on. And people got interested in this, I think, because they thought, oh, here's an alternative. I'm afraid of what's going to happen. They're talking about oil going to $100 a barrel, and all heck's going to break loose. So people put these things in based more on just the operating costs. And I guess that's still some of the issue. I don't really like that much. I think what I've turned into is, if this can work, is a capitalist environmentalist. I don't know if there is such a thing, but I think that's what it's like. I like money, but I like the environment too. It seems to be a bit of a rare issue these days. The utilities are just, they came to us probably, Dan, what, 3 or 4 or 5 years ago, and said, there's something else going on here. You can cut the demand or the peak. Peak to me is like a mountain, it's not a, what's your peak? And we had an installation, I believe it was done in North Dakota, and the utility and the university up there monitored these systems and showed that we were saving 65% of the peak demand. Getting that across the utility is very difficult. EPRI did a bunch of things. I think it's slowly growing. But the thing about that I look at as utilities, I had a friend tell me there's a thing called inertia. Utilities are all large. Ontario Hydro is about $7 billion in sales. They have about 30,000 megawatts of power and about almost $40 billion in assets. It's the largest company in Canada as far as assets. It's a monster. Trying to get that turned is real difficult. But there's a thing called trim tabbing, and it's when you go all the way to the back of the ship. If you're going to try to steer a ship, you don't push in the nose of the damn thing. It's just not going to work. It's going to run you over. And the guy said, what you do is you go all the way to the back, which means you've got to go through all of the things and all the departments and all this stuff and try to figure out what's going on and find out where the engine room is. And if you can find the rudder, there's a trim tab, and you can turn that with your finger. So really what this peak demand is, and I guess it doesn't matter, what Mike really shows me is there's a potential here beyond just demand savings for a peak loading situation like Ontario Hydro saying, well, we're out of power. We have to do something, to another utility that has excess power that can also make money marketing this. It's a very rare situation. Probably one of the biggest problems with the technology is that the energy is free. If it wasn't free, everybody'd be selling it. It's very difficult. This really has only hit me in the last, well, it's in your backyard. It's yours, you know, you don't worry about it. It's, Doug Rice says that 80% of the people don't think. I think it's a little higher than that. We've been walking it. I drive to Toronto every day, and I probably drove on enough energy to heat the city. But we're fighting over it. You know, we're fighting over energy. Because oil is in Texas and Oklahoma and Saudi Arabia and Iraq, and you have to bottle it all up and get it to you. It has some value. If it's free in your backyard, it's not worth anything. Seems a little, kind of hurts, you know, but that's, plus at the same time, the environmental side jumps in and says, well, maybe we've got 30 years of oil. If we burn it, we're probably dead. Good shot. You know, they've had all these nice scientists. The people that send the rockets to the moon, the ones that we trust to do that and run space shuttles and the rest of it, are the ones that sit down in these meetings and look at all the data and spend their time studying it and saying, hey guys, you got a problem here. We don't know when it's going to hit, you know, but this is a test tube. You know, we're all kind of stuck in this test tube, and we don't really want to do anything about it. But I think with the, we call it earth energy, geothermal, solar, whatever you want to call this thing, there's a potential to clean the environment and at the same time make a bunch of money. I think there's more money on the demand side than there is on the supply side now. If that's the way if we can look at it that way, and we can have the financial people and other institutions or whoever, DOE, Lou Pratch, Admiral Watkins, all these different people involved in taking a real hard look at how we can make money with this, I think we can clean the environment up, and it could happen very fast. At the same time, there's been some people, some megatrend type people that have looked at it and said, well, wait a minute, you could probably do something for the economy pretty drastic. So retraining, there's a whole new thing taking place here. I'm going to go through a slideshow that kind of tries to visualize what I'm getting across here, and doesn't have a lot to do with the pipes in the ground or the houses or anything. It's mostly graphics, because most of what I'm talking about doesn't really exist. So it's you got to try to draw it, I guess. I'm going to need the lights down quite a bit here. Some of these slides are a little dark. Okay. Development. This is what Peter and I probably sit down and try to figure out how do you develop this industry on a more of a North American focus, not just one utility here, one utility there, or one area here, or one area there. This is what's happened as far as our consumption of energy. Where's that pointer? Somebody got... No? Doesn't matter. You have a primitive man, their consumption wasn't very much. They lived in the ground. See that? In caves, you know, they used the Earth's energy to heat them, keep them warm, similar to what we're trying to do here today. The hunter did a little more. He burned wood, he cooked, he did a lot of traveling. He probably required more food. Simple farmer, mechanical farmer, industrial man, and technological man's gone right off the scale. We don't even want the temperature in our house to drop 2 degrees because it's not comfortable. You bring a caveman in, I think he'd just think this was great if it dropped 10. You know, he'd be real happy. So what this has done by us accelerating our energy use is we're using fuels that are very old, for one thing. What we have here is a planet. You know, we run around our day-to-day things and we don't really pay attention that we're living on this planet. And it's floating around out in space, has an atmosphere around it. It's kind of rare. And it's heated with the sun. We don't really pay a lot of attention to that. I was just out in Newfoundland. I don't know if you have Newfie jokes down here, but we got lots of them up there. And they suit sometimes. But you know, when I was actually putting an installation in myself again. Went out and put a loop in the ground, put the pipes in, hooked up the unit, did all this stuff. I haven't done it for years. It was a lot of fun. But when I was pushing this thing in the ground, what I was really thinking is what I'm doing is I'm tapping into the sun, not the ground. It's like, I think Dan said last night, well, you know, there's fusion. Well, that's what it is. That's really what the energy source is that we're getting into. This I stole from Harry Bro. Hit me really hard. I saw it, I think, up in Canada. I don't know if you showed it here or not, Harry, but this gives you some idea of the amount of energy coming in to keep the planet and the atmosphere warm. 9% reflected into space, 23% cloud suspended particles, but 47% of all that energy coming from the sun is stored in the ground. Ontario Hydro put out a brochure about 10 years ago on solar, and it said, the Earth is a great solar collector. Put panels on your roof. I'm serious. It's right in the brochure. You know, I looked at this, and even had a picture of the planet. You know, I looked at this, and I went, somebody's, you know, think, you know. So that 47% in a measurement is, I think Darlington Power Plant is our new, I was going to say fiasco. Is there anybody here from Ontario Hydro? I don't think so. It's a new 4,000 megawatt nuclear plant. It's coming online. It's cost them about $5,000 a kilowatt to get it on stream. Pretty bizarre. That 47% is about 2,000 billion of those as far as input daily. Uranium's kind of old. So what we do is you've seen all these pictures, we have a way of just putting some pipes in the ground and heating the home with it. Using that fusion energy or solar energy or whatever you want to call it, geothermal or earth energy or whatever, heat pump, doesn't really matter. It's what it does. I think we get so hung up on the boxes, you know, that we forget what it's doing. It's like we get so hung up on our cars that we forget what we do with them. You know, it's strange, or our weapons or whatever the heck else we get hung up on. Put them in horizontally, put them in vertically, doesn't matter. As Jim Bose says, you take a bunch of pipe, you dig a trench, you throw it in the ground, you heat your house with it. It's real tough. I think the companies that I've been associated with, as far as I know, we've got probably between 25 and 30,000 systems of these things in, and I really don't know of any that don't work or that you couldn't have fixed easily. It's not that we don't have a lot of arrows back here, you know, but it's so what the net result really is you end up with 1 kilowatt of energy going in, whether it's from electric utility or from gas or from whatever else we can figure out to drive it with. And you get 2.5 kilowatts from the ground. That's kind of a leading edge ground source unit. 3.5 kilowatts into the house. Problem is that's that free thing there. You know, free is probably a bad word. It's kind of like a lottery. Heating system efficiencies gives you some idea. Ground source, air-to-air, electric, high efficiency, natural gas, oil. At point of use. Now here's another thing that comes up. The environmental side starts popping out. Is if you use natural gas as the source fuel, this is a little hard to explain, but the delivery system efficiency of the different fuels is very important. It's not just where you burn it, it's how you get it to where you burn it. 35% efficient for electric. In Ontario, they're telling me it's between 35 and 40%. By the time they get it to the house, the delivered energy for what they use, whether it's coal, oil, whatever. They're telling me natural gas is 80%. Ground source heat pump is at 350% efficiency. If you burned natural gas to extract that heat from the ground with a Stirling engine type technology, might be 200% efficient. Is that good, Dan? Is that a good number? It's around there. Get a lot of waste heat off those things. So you end up with 160 to 123. Now, the other thing that comes out here is that natural gas units really don't exist in the marketplace. They're totally experimental. So this is what we have. We have a situation where our delivery system efficiency, same numbers, high efficiency gas system that's available right now, condensing gas is 90% efficient. The end use efficiency of a ground source system is 123%. We're 51% better than gas environmentally. And there could be arguments. They say, well, we don't give off as much CO2 or we don't give off as much sulfur and all this other stuff. But methane's starting to jump into there. They're having a problem with methane right now, finally. And this gives you some idea of the sulfur dioxide, nitrogen oxide emissions per system compared to its resistance in air-to-air. So we're 1/3 better. We have free energy in our backyard that's inexhaustible, renewable, and everybody isn't using it. And there's utilities coming in with grants. The system already pays for itself. It's like Doug up here trading dollars with you, but nobody seems to want to do it because it's more than $10 increment, right? And we get real comfortable with our normal technology. So now we've got some steam, we've got oil and gas, and we've got what we call earth energy in Canada. Those ones are old. Steam, I don't know how old that is, geothermal energy. Oil and gas is between 30 and 70 million years old. So when you burn it, you burn something that's 30 to 70 million years old. Ground source, when you burn it, is 30, 40 days old. Makes a lot of sense if you look at it in that context. It's a lousy slide, but it gets the point across. What we've always done is supply, demand, right? We create the demand, then we throw in the supply. Create the demand, we throw in the supply. All of a sudden we get this little thing in the bottom called environmental impact. All that stuff up top isn't really worth a lot if we don't make it match the environmental impact of what we're doing. The only magic about this one is that there's probably more money there. I'm not smart enough to figure out how, but I know there's people that are. Obviously, there's something came out, some utility that Mike said that I didn't even catch it, about the loops. You know, somebody has to explain that. So you put in these things, you get rid of the oil. You can tell Saddam to go back to the desert, you know, go back and play in the desert. What it does for the utility, that's actually a monitored system in Syracuse. Shows a savings of about between 6 and 8 kilowatts peak day, localized non-polluting energy savings by the utility and the consumer from the earth. That's the increment between those two peaks. Well, the one peak, the other one's kind of flat. So that's where the utility starts to win. Here's how we sold the utility in Canada. There's 450,000 electric resistance homes in Canada right now, where there isn't gas. Earth energy systems on an average save 5 kilowatts demand, which computes to 2,250 megawatts of savings that are available in each customer's backyard if the utility wants to get at it. It's generating capacity also. It's not just demand, because it's doing something with it. It's supplying energy to the structure. A generating plant costs $3,000, so you spend $6.5 billion to build those 2,250 megawatts. Now that's a low number. That $3,000 is low. It has nothing to do with maintenance. It has nothing to do with cost. We just had Pickering, which is another nuclear plant. It's 12 years old. They spent $1.3 billion putting new tubes in the reactor. I think the plant only cost $6 million. Earth energy systems cost approximately 600 kilowatts to install. $600 a kilowatt to install. So that's that same thing. We got that 2,250 megawatts still sitting out there. If you put in that same amount of capacity with ground source, you'd have $1.35 billion to spend. So you'd save $5.4 billion in the process. The consumer can afford to pay a significant amount of installation costs because his savings are so high. If the utility wants to get involved and do something, he can do it. And the customer can then afford to pay for the balance of the system cost because his savings will pay for it. It's like Doug was saying about, it's like an annuity. Pays you to own it. The operating savings are tax-paid dollars. And again, and down here, even the interest is deductible. If you save money that you would have spent, it's tax-paid. You got to make $1,400 to get that $1,000. Understand what I mean? If you're saving $1,000 that you don't have to pay it out, that's non-taxable. So there's another benefit there, plus the interest is deductible. The utility benefits by substantially stabilizing their demand load, and the conservation offsets the need for new plants lowering emissions. The intangible benefits promote technology with lowest in heating cooling costs, obviously. Total comfort, heating, cooling, and domestic hot water, most advanced environmental system and renewable energy source, utilizing the customer's own property. I don't know what the hell, I don't know what more people want as a technology. The societal benefits in North America are that Earth Energy Systems generates a great deal of employment. A lot of this is labor. Manufacturing, heating contractors through massive retrofits, not just new housing. The utility can afford to retrofit. In Ontario, this thing's targeted at retrofits. There's 281,000 mailings going out right now to customers with 3 dealer names on them with phone numbers for retrofit installations. Excavation contractors, education and training, electrical contractors. 100% of the customer's expenditure remains in the North American society. So, we're going beyond this, the heating and savings costs. We're getting into something that has some societal benefit beyond environment, beyond a lot of things, demand side, beyond a lot of things. The more I stay with this, the more I start to see more of what's available by utilizing this energy source. For some reason, I think it just fits. By utilizing geothermal technology, North America has an indigenous renewable energy source at each individual location of use. I keep drumming on that because it took me years to figure it out, so I'm trying to... Now, why doesn't everybody do it? One of the problems is how do you pigeonhole it? What department are you going to stick it in? The Minister of Energy in Ontario and the President of Hydro and all these guys got together and said, your problem is nobody knows what you are. You're all of these: solar, geothermal, renewable, alternate, demand side, conservation, heat pump, cogeneration, waste heat. It does all of that thing, all of that stuff, and it uses a free source. It doesn't have to use the effluent from a manufacturing plant for cogeneration. It pulls it out of the ground. It's alternate to anything else. That's kind of... So we said, okay, what's the problem? Since this thing's so great and nobody's using it, what's wrong? So we said, okay, let's see if we can identify the problems. These don't all have to be read. It gives you some idea of what's going on. No technical, no public awareness, no endorsement, no government procurement, nothing was being bought by government utilities or government anything. You go to Ontario and there's solar panels all over the government buildings. I think they spent $27 million on solar programs in Ontario. I was at this 10 years before they did anything. I don't know why. I still don't know why. I think why they had to do it is we just got so mad that we used any leverage we could possibly use, whether it was environmental groups, newspapers, whatever we want, to go after the utility. That's what we did in Ontario because we tried everything else. So there's no resolution of environmental issues, low visibility, narrow geographical and sectoral concentration. All it is hotspots. We got a hotspot in southern Ontario. We got a hotspot in Indiana with Vance territory. We got a hotspot out in the east or out in the west or down in Arkansas or something. It's just sitting around. There's nobody really pushing it. wasn't involved. They are now. No technology transfer to influence sectors, little generic information. All you had, as far as information was concerned, was the stuff that came from the manufacturers. You didn't have something else out there that said, hey guys, here, look. This is something that's been monitored, somebody's taken it, and really check this thing out. Little engineering capability in the non-residential market. Lack of quality assurance and standards. That's another thing we're seeing here. Ductwork in weird places. Really no standards in place. Mike's got a great thing going because he's using somebody that has a lot of experience and all the loops are inspected. No education, no engineering resource material, improper use of high entering water temperature equipment. That was a major problem. We had boiler cooling tower equipment coming into Canada where we've got 10 and 12,000 degree days. Like, you're saying, we've got systems in that are actually sitting in 11 to 12,000 degree day heating areas. They work the best there. Colder it is, the better. Bigger the heat loss. Just put a little more pipe in the ground, works fine. So then we try to identify, okay, what's the future? Who do you have to satisfy with all of these things? You have to satisfy consumer, industry, the utilities, environment, and government institutions. So you got to make all these people happy before any one of them is going to really push it or accept it. On a large scale. I'm not talking a local scale. I'm talking almost a global scale. The consumer must be satisfied. Confidence, awareness, accessibility, and satisfaction after the sale. They must be able to get a hold of it. They must believe it in the first place. They must know where to get it. And then they also have to not worry about it after it's in, because it's a new technology. And it's not really new. It's different. Industry training in all aspects of earth energy. Some of the manufacturers have very in-depth training courses. We do generic training up in Canada to the CSA standards. Awareness of the technology, accessibility, marketplace that accepts earth energy. You can go beat your head against the wall. Somebody as big as an electric utility can't go out there and create the awareness through their advertising if they wouldn't have really, really looked at this hard like Mike did. Just don't have enough bucks to throw at it. So you have to somehow see how it's to your best benefit. Utility and government awareness and support by distributors. Utility training again, awareness of the demand load benefits of the technology, and how do you make money with it? Putting the numbers up in front of somebody is one thing. Getting it up to the VP levels and to the controller levels, well, they'll sit down with their financial department and say, okay, there's free heat here. How can we make money with it? Because we're in the best position to do that. If you don't do it, somebody will, because the energy's not going to go away. Somebody will figure out how to do it. It's been here a long time. If it isn't here, we're all dead anyway. So it's they have to have all of these things, and they need a low-risk method to introduce incentives, which means the training, accreditation, good distributors, all the other stuff. The environmental interests are satisfied by providing training in all aspects of Earth's energy, awareness of the environmental benefits. I've actually got people in Canada that were attacking ground source, environmental guys. Well, they'll attack anything, you know. They attack anything, you know. I don't know what the hell I'm talking about, but I'm going to attack you. So you pull out your gun and you shoot him. And then he gets up and goes, geez, it makes sense. I said, well, it's, you know, good. It's glad your ears are open. Low environmental risks, involvement. They have to be involved in the environmental impact analysis. Otherwise, you're going to be doing a lot of things wrong. They're going to get ticked off, and then they're going to come after you. It's better not to have them do that. Get them in up front. Let's all, hey guys, this thing's great. Let's figure out how to use it. This is the energy source. There's no other energy source on the planet that's even close. That's what keeps the planet warm. You know, let's figure out how to use it. Government, almost the same. So, you know, you do have a lot of overlapping things. Once you know how to do one with one body, you can also take that, transmit it over to the other one. You don't have to recreate the wheel every time you go to approach another segment. So we created this association. Peter and I sat down and bashed out this association over, I think, a bottle of scotch and looking out over the Ottawa River one afternoon, eating steaks, trying to figure out, okay, we got all this stuff, we've written it all down, what the hell are we going to call this thing? So we called it that. And we tried to figure out, okay, where are we at? On the left is a megawatt savings scale, okay, of how many megawatts we can save with this technology, which means, or save or supply with the technology. Over what period of time? Right up to 1996. As you can see, I've got on the left, on the right there, this is where we are at spring of 1990. Why that's important is May 4th, Ontario Hydro announced their program. So we were almost into the accessibility threshold at that time. There was already probably 7,000 or 8,000 ground source systems in Ontario at that time. Put together a strategic plan. Another thing that's nice about standing up here now is that all those things are done. don't have to talk about what's going to be done or, oh, we're going to do this or maybe this will work. There's CSA installation standards that are in place. They're being upgraded right now to fit more environmental concerns. If you don't put them in by that, you don't get the incentive. There's an industry directory, which I think there's 19 manufacturers in Ontario now. 19 different ones. And they're all doing incredibly well. The industry's up 60 to 70% in a recession. There's CSA performance standards. Each unit that comes into Canada has to make sure that it's not one of those low entering or high entering water temperature pieces of equipment. They have to make their claims. Ortec, which is a research lab, is about a $300,000 lab that was put together. It's been calibrated, and what they'll do is they'll reach out and pick one of your units and stick it in their lab. If it doesn't fit, it's going to cost you, because you're going to have to make it fit, so that we know that we're putting systems in that are going to perform. There's Industrial Codes of Practice Conformity to the Energy Efficiency Act, which was, we were the first HVAC technology to go in there, obviously, because we're so much more efficient than everybody else, and we got a lot of publicity out of it. Consumer and Utility Conference, there's engineering reference manuals, national training facility, accreditation of companies. Each dealer that's in underneath the program has to be accredited. I'll get into that a little more. The CEA provides databases of equipment for the Energy Efficiency Act. So if somebody wants to know what's available, wants to be a new dealer, you can call up and get the list. All companies associated with the industry, all accredited dealers and contractors, and all qualified personnel in the industry, people that are members, that are either engineers, architects, whatever, that are promoting the technology. So if you've got a commercial job you want to have designed, you can call somebody up and have it designed. The guy's not doing this, he's doing it because he's interested in it. All installations undertaken, and they've got a complete list of all installations undertaken through the Ontario Hydro Ground Source Heat Pump Program, which means that's done on a weekly basis. I believe when I left, we were at 1,250 applications since May 4th. CEA in our company, Mike, I've got a company, D.L. Hatherton Associates. We provide all these services to the CEA. All the training and the accreditation, the manuals, and all the other stuff. I've got 3 people that work with me who've been in the industry for quite a while, and they're very good. We provide training for residential dealers, commercial contractors, utilities, government bodies, environmental groups, anybody who wants to know about it. So this implementing an earth energy demand side program, this is what we did with the utility. Tried to figure out, I've got some overheads here, but I don't think I've got an overhead projector. And it would go through the flow of exactly what we did, piece by piece, to make the program work. It took us 3 years for this one. And here's the program. It's a cooperative program between Ontario Hydro and the Canadian Earth Energy Association. Basically, what Ontario Hydro does is take care of a lot of the promotion and the costs, and they actually finance the program and promote it, and the CEA administers it for the utility. So it keeps the utility. If anybody's got a complaint or anything, it's handled by Canadian Earth Energy Association, not the electric utility. The inspections are handled by employees of the CEA. They're actually contracted to the Canadian Earth Energy Association. The dealer requirements, they have to be a full voting member in good standing of the CEA in the dealer contractor category, sponsored by one or more recognized manufacturer distributors, which means that's the guy that's had the equipment tested. So we know that he's representing a piece of equipment that is in under the standard, the performance standard. Each unit that comes in is labeled by the manufacturer so that when you walk in to inspect the installation, there's a label on it that says it's a CEA approved piece of equipment. Carry third-party liability assurance of $1 million. That's just that we don't get on the stick. And must be an Enermark contractor, which is like a marketing contractor. There's financing plans that are done by Enermark. There's advertising, and they'll list it. They'll put your name in their trade show booths. They do a lot of things. At least one employee must have completed a proprietary service training from the manufacturer. Now, what this was is it was a grandfather clause when the program was put in place, because we couldn't train enough people. And it was a one-year program. Ontario Hydro said, we will not have the manufacturers' programs themselves accredited because it may not be to the CSA standard. which is the same as being a refrigeration guy or anything else. That's what's happened up there, and Ontario Hydro said that's the way it is. We want that to stay like that. Successfully completed training provided by the CEA. Now that's the standard. You have to be in there. During each calendar membership year, which means you have to come to a one-day training every year, which is an upgrade on the standard to tell you what's going on. Otherwise, the utility will pull out. The accreditation and certificate programs cover an industry overview. They go through thermal fusion and hands-on, collector system design principles and closed loop, totally generic. It's nothing to do with anybody's product. They can take the BTU requirements, they can take whatever they want off of anybody else's equipment and size their earth loops to the program. Installation requirements, sizing techniques, and it shows them how to fill out all the forms for the program. They run a step-by-step program through the consumer and everybody else. They play these fill out the form games, and they have an exam. There's also a 3-day Earth Loop Contractor ELT program that's available in accreditation for the loop contractors. We've had about 50 people go through this. We've had 400 people go through the prior one. And here's how the program works. Actually, it's $2,345 from the utility. $180 goes to the CEA. $105 of that goes into a trust warranty fund. So if the manufacturer goes broke or the dealer goes broke or somebody doesn't want to take care of the consumer, he can call up the CEA, will to go after the dealer. If the dealer decides, no, I don't want to do it, I'm not going to deal with that guy, we'll go fix it for nothing for the dealer, for the customer. Problem that Ontario Hydro had was that they got in behind heat pump programs in the past, and they ended up eating a lot of stuff. $75 goes for the administration, all the paperwork, all the reporting, the maintenance of the database, and the maintenance of the CEA itself. $165 goes to the contractor after the contractor's paid it to the CEA. It goes in a circle. It actually goes to the inspector. Each system is inspected by a CEA quality assurance manager. He goes out with the dealer, checks the thing out, checks his paperwork, makes sure that everything's okay, talks to the homeowner, and he gets $150. $15 goes back to the contractor. And $2,000 in cash goes to the homeowner. So what we do is we provide the services to set up those programs. What we did is we worked with Peter to set up the programs to implement the complete program from stem to stern and work with the utility to say, okay, here's what we think will work, like the mailing, like the training programs, like all of the different components of the system. It looks like we'll have 6,000 systems going into the program next year. That's the target. That's about, how many megawatts is that? 6,000, I don't know what it is, 15, something like that. No, it's more than that. It's probably about 30, around 30 megawatt reduction. So you provide training, earth loop installation to CSA standards, earth loop sizing, earth energy software, sales and application training. Marketing and services and consulting, we'll do consulting or we'll hook them up with different people that can do the consulting for them, engineers and architects. Market development. We'll do pretty well anything that's got to do with it. I'm not in water furnace anymore. I haven't been in it since March. I got out in March. I haven't got anything to do with, except I'm still a major stockholder. The Canadian company went public back in March, so I got out of that and got into this, and I want to see it push with utilities. Design and application services. These are the kind of services we'll render. Research and development, system application improvements, load identification, equipment matching, demand side management to structure optimization, installation flexibility analysis, logic controls. So what it comes down to is it's part of the solution, not part of the problem. Burning the existing sources we have is somewhat of a gamble in two fronts, or actually probably three fronts: economics, availability, and environment. We've got three fronts that are quite risky, the way we're proceeding right now. I don't think the status quo of what we're doing is going to stay, and I'm not sure that we want it to. I think it's time for us to change a little bit in the way we do things. And I think it's going to be very exciting. for everybody. Am I over here? Getting close. So it's what it comes down is it's energy for North America or for wherever else you want it. Doesn't matter. It'll work probably anywhere. In Sweden, most of the installations are above the Arctic Circle. You know, and they work great in Phoenix too. So you just have to figure it out. Dan's slide presentation has been something I've wanted to see for quite a while. I've never sat down and bashed the numbers like that. But when somebody sits down and does, I don't think anybody's ever done that before. Sat down and just bashed them. I've looked at him and said, this doesn't make sense, but I never sat down and, of course, he lives with a Hewlett-Packard computer in his pocket, so that makes a difference. So if you have any questions, that's kind of wraps it up. Okay, thank you.